Welcome to a read along with Dr. Pal in the book Discrete Perspectives in Mathematics. This is subsection 5.2.5. Okay, so what we've been talking about is how to make a map right here that goes from Z mod 3Z cross Z mod 4Z to Z mod 12Z. And we've seen that we can consider lifting everything to free Z modules where it's easy to make a map that's well defined by just knowing any destination at all for E1, which lives in here, and E2, which also lives in here. So we take E1 and E2 and we find destinations for them over here. It doesn't matter which destinations we pick, this map up here will be well defined. However, we want this one to be well defined down here, and it matters which choices we make up here so that this map is well defined. Now, in our particular choice, see this 3 and this 4? They're relatively prime, which means they do not share any common factors with each other. And we're going to be using that idea as we move along. How do we make sure we have a well-defined map? Essentially, what we need is that 0 is sent to 0. So let's look at that picture by the identity to identity criterion. Meaning if we take 0 here, we take its pre-image, we send it here and send it down, do we get 0 over here? And if we do, we have a well-defined map right here, defined by the commutativity of this diagram, pre-image over down. That's all we need to do. Just so that 0 goes to 0 and we're good there. So what we do is we take everything that represents 0 down here, look it up here. Well, that's simply going to be multiples of 3. In fact, let's just kind of write that out. That's simply going to be multiples of 3. So it's going to be like 3z and multiples of 4, so 4z. And we send that through h, so like h of 3z comma 4z. And then we put a bar over it to send it down. So basically when you send it down, it's like putting a bar over it. And the question is, where do we land? Do we land in multiples of 12? Okay, so is this 0 bar? That's kind of what we're after. Okay, and that's what that little subsection talks about. What conditions do we need to impose on h of e1 and h of e2, knowing that 3 and 4 are relatively prime? Okay, so that to make that happen, so that we actually get f being well defined. So we run 3z and 4z into h, and run it down the chute to see what it's going to look like. We're looking at it before we merge down, so right here, and so we're just kind of making at the last merge. So we're just trying to see if this is a multiple of 12. We get to this point right here, and then we think, okay, we want this to be a multiple of 12 in order for 0 to be sent to 0. So what's true over here? And we're going to use the fact, I'm using the fact that 3 and 4 themselves are relatively prime. And the way we can do that is, if we want to focus, let's just focus on h of e2 for a minute. To do that, let's just mod everything out by 3. If we mod it out by 3, this goes away, just be 0 and 0. That's so we can concentrate on this and look at it in more detail. Now, this needs to be true for all s values and t values, because those are arbitrary integers. So in particular, it would be true for 1, for s is equal to 1. So in that case, when s is equal to 1, then what we could, so let's just look at that. We mod it out by 3, so that's what the red bar means. We think of that as a 1, so I'll just kind of get rid of it. Think of just 4 times something. So if we could multiply both sides by the inverse of 4 mod 3. And we can do that because 4 and 3 don't share any common factors. And then we're left with h of e2 is just 0 mod 3. So in other words, 0 So h of E2 is equal to something or congruent to 0 mod 3. So E2 is sent to something 0 mod 3. Okay, that's what we have. Now, similarly, using a similar argument, you can actually have E1 is sent to something that is congruent or 0 mod 4. Now think about this. This is E1, think of it as like 1, 0. Think of E2 as like 0, 1. So remember the first component was mod 3. See that 0, mod 3. See how the second component here is 0? And that was mod 4 in the second component? 0, mod 4. Okay, so essentially what we need is E2 to be sent to something that's a solution to 0 mod 3, and E1 to be sent to something that's a solution to 0 mod 4. As long as 3 and 4 do not share any common factors, then this right here is the guarantee of the map being well defined. All right. So we've just shown a condition for F being for the map being well defined. Thanks for watching.